Okay, let's continue from the hashing topics for hash table. Let's just quickly review what a hash table is. So what we started with last time was to talk about what does it really mean to hash your key for the map. So that's kind of the conceptual idea over here. So you have some key, k, which in general can be an object. It can be integer, can be string, can be anything. And then somehow you undergo some process called hashing. And then you will turn the k into some integer value. In this case, hc stands for hashCode function. And then the hashCode can be somehow used internally as the index of some array. And then indexing into the array is going to take some very efficient way of retrieving the value. That's something we talked about last time. Any question about this concept over here about hashing before I move on? Okay. So for your lab number 3, if you want to define some hashCode function, in your case, it's actually quite straightforward. You were already given explicit instruction as to how you can do it. And what I would like to show you is on the Eclipse in just a moment to see how you can generate the hashCode function quite nicely, very professionally, I would say, by Eclipse. I'll show it to you in just a moment before I conclude the topic for hash table. Okay, so now let's just go over to this question over here. Remember what we said before, this is the only requirements you have to bear in mind in order to define your hash function. You want to make sure any keys, they are actually equal. In this case, K1 and K2, the equals method here depends on how you override it in your own class. If the keys turn out to be equal, then the hashCode must be equal. I will show you some cases where you forgot to override your default hashCode inherited from objects. You'll get some very funny behavior. That's something you want to avoid. I'll show it to you in just a moment. Okay? So now I want to go over some discussion for this particular question here. Okay, so now you can see that we have a class called integer key. And we choose to override the hashCode function there. I say, whatever k is, I'm going to modulo 11. That's what we went over last time. Now, this is the standard way of defining the equals method as we talked about before. Okay? Let's say we want to replace the definition of the equals method here by simply saying, okay, return this.hashCode equals other.hashCode. The question is, would it work? Right? That's the question here. Okay, let's have a quick look. So this is really important here to really know how you should define the equals method rather than just using hashCode to define that. You got to be very careful. Okay, so now let me just do some illustration here quickly. So now let's try this. So now let's say we have our class over here called integer key. I'll say IK, integer key. And then we have our hashCode function over here being overridden. hashCode over here, of course we have some integer which is, let's just say k. Okay, that's the attributes, private. And then over here we simply say return k modulo 11 over here. And now the question is, if I define my equals method in this way, would it work? So Boolean equals over here, object other. Okay, that's a signature for the equals method. So now if I simply say return k dot hashCode equals other dot hashCode, would it work? It's really important to realize why it will work and why it will not work. First of all, I can give you a little bit hints. Okay? So let's say this. Let's try to see what we expect from over here. Let me give you a little bit hints. Let's say we have some client code over here. Let's say we're trying to make use of this new version of equals. Let's use it this way. Let's say we have some client code over here. Let's say we have integer key. Let's say k1 is assigned to new. Let's say some integer key. In this case, I will simply just give to you, let's say, I don't know, maybe 39, like that. Okay. And then I got another integer key, let's say k2. New, let's say ik, and then 6, for example. I have two keys, k1 and k2, okay? First of all, let's answer the question to ourselves. Should these two keys be equal or not? No, right? Because they're simply not, right? One is about 39, the other one is about 6. However, let's see what this new version here is going to work for us. For example, you can see here, we simply say, now return this rather than the usual definition we had. So now I want to draw your attention to this. Over here, we have hashCode method here, and also we got hashCode method here, right? So now, let me just try to make a method call here. You say, now k1 dot equals k2. If I try to make this method call over here, apparently it is going to call this equals here. And then you can see that the context object is k1. The argument is k2, right? So here you can simply say, so actually this should be this. I forgot about that. Okay, this. So this will be k1, and other will be k2. So you're basically comparing if k1's hash code is equal to k2's hash code. In this case, are they the same? They are, right? Because 39 modulo 11 is 6. 6 modulo 11, 6. So their hash code are the same. So now what do we have over here? You have two keys that should not be equal. However, the hash code turned out to be the same, which will give you the wrong result. Okay, let me just finish this and then I'll get back to you. So what this will give to me is simply true. However, this true should not be the case. I'm trying to prove to you that this definition for this much simpler definition for equals method is not appropriate because you run into some dilemma, which is what I said before. Remember what I said before? I said the only principle you have to obey for hash code is you want to make sure if two keys happens to be equal, and then they must have the same hash code, right? Okay, any questions about this? Yes, go ahead. It's a very good question. I want to delay discussion. Yeah. Okay. I want to make this discussion not too long, but I will explain to you since you asked. Okay. The question was, isn't the type for other over here objects? I agree, it's objects. Sorry, except I spelled that right. Okay, objects over here. So now, remember hashCode. Where does it come from? hashCode comes from the object class, pretty much like the equals method. So there are three methods we have to learn for this course. We learned about equals. We also learned in hashCode. There's another method which you learn about called toString in 1022. So now, the reason that we can make this method call without casting is because the other variable over here is declared as objects. An object does have that hashCode method defined. However, now the question is which version of hashCode is it going to call, right? So this has something to do with something called dynamic binding, which I want to delay a little bit until later, okay? But for now, what I can tell you is the hashCode over here and the hashCode over here, both of them, they're going to call this version here, okay? Because K1 and K2, they are really just integer key. So they're going to call the right version, which will do the modulo for hashing code, for the hash code. Okay, any question here? So, for example, if I give you any proposed maybe hashCode function there, so I will ask you if the hashCode itself is appropriate or inappropriate. How do you either prove it or disprove it? If you want to disprove it, give me one counter example where two different keys will, where the same key will actually give me a different hashCode or vice versa. Okay. Okay, if no questions, I'll move on. Any questions, guys? Maybe you need some time to digest, maybe? Okay, maybe you can look at the slides. Okay. Okay, so now I want to just mention something here. So that's the code I already gave to you. Okay, we got hash table here. So now this is why the hashCode function or method is actually useful. Because the hash table is one of the library classes they can make use of. But in order to use the hash table class, you have to make sure you define the hashCode method properly. But what if you haven't? You'll run into trouble. Okay, I'll show you in just a moment. Okay, this one's still easy. Okay, so that's still from last time. Okay, what I want to show you is, okay, what about showing something very quickly here? How do you generate hashCode from Eclipse? Okay, it's very easy. So first of all, let me just go back to Eclipse over here. Okay. So you still have, I just added something new to the, your sample code. I already uploaded to the course website. Well, I'll go over that very quickly in a moment. So now let me just say this. Let's say we have another class to illustrate how you can generate hashCode just using Eclipse. Let's say we have a package called point key. Let's use our familiar classes called point, and we want to generate hashCode from there. How do we do that? So let's have a new class over here. Let's call that point. Okay. So now, in the point class, let's make it simple. Let's say we still have double x and double y. So now, how do we define a hashCode function? What Eclipse can do for you is going to generate, so based on the attributes you want to consider, and generate the equals method and the hashCode accordingly for you. Okay? So now let's say I want to define my equals method and hashCode, both methods, based on x and y. So these are the two relevant attributes I would like to consider. So select the attributes you like, and then, or you can just right-click on the class, doesn't matter. So if I select them and then say right-click, you will see that under source over here, and then you will see one of the options is generate hashCode and equals. Okay, so they will do that for you. If you choose that over here, so now you can see that because I highlighted the two attributes, so they're going to generate the equals and hashCode based on these two attributes. If I only want to involve one of them or some of them, you can simply just choose one of them. Okay? So now I can say OK. So what you will see is now we have override hashCode. And somehow you don't really have to worry too much at this point how the magic actually works internally. Somehow it's guaranteed to be a good hash function. Okay? So that's for the hashCode. And then for the equals method here, you'll find that it's very similar to what we taught before. You can see I have the different cases there. But I would say try not to rely too much on the Eclipse because you should always understand the logic. You can just write it out by yourself. Okay? Again, as far as this course is concerned, for the hashCode, so first of all, you have to override it usually for your class, almost always. Now, how do you override it? You got two choices. Either you are given some explicit instructions how to override it, like for your lab number 3, or you can simply use Eclipse to generate it. Okay, so these are two options for you. Okay. Any question about doing this in Eclipse? You might find it useful, possibly in later courses. Just want to show you quickly. Okay. So now I think there's one more set of codes I would like to show you for a hash function. So let me just go there. Do I have that here? Give me one moment. Give me one moment. I'll find out the slides. Contracts for equality. Defining hash function here. Somehow this is the old version of the slides. I'm not sure why. So bear with me. I'll just get it out very soon. Just give me 30 seconds. You'll be done. Okay, so now I'll get the slides. 11. Hopefully there's a new one. Okay, so now let me go to the hash function there. Okay, I'm pretty sure that's a new one. And then I'll go to hashCode, and then I'll start again. Okay, that's a good one. Okay, let me just go to the code I want to show you. Okay, so now let's now see this is going to be the final bit I would like to talk about for hashCode. So now there's a warning for you, as I said before. You have to always make sure the hashCode and equals method, they are somehow defined or overridden to work together well. I'll show you one case where it is not the case. Okay. So now let's consider the integer key class again. Okay. Let's say we got integer key, we got integer attribute there, and now let's say we do not try to override the hashCode method. Let's say we do not try to do it. What does that mean? That means it's going to use the default version that's inherited from the object class. Okay, and we'll see how bad it could be, okay, the default version. However, on the other hand, even though we are not trying to override the hashCode function, we try to override the equals method properly. Okay, so this is kind of what we are having here. Okay, and now, so what's really the problem here? Okay, let me just briefly describe very quickly, and then I'll show you some Java code. The default version of the hashCode that's inherited from the object class is simply just going to, every time when you create a new object of type integer key, it's going to generate a unique integer for that new object. Okay? Every time, it doesn't matter how, even if the contents are the same, as long as they're different objects of integer key type, it's going to be different hashCode. Okay? You can already see what the problem is, right? So let's see some code over here. So what the problem is, you really have to see the contract for the hashCode that we keep mentioning. If the keys are the same, they must generate the same hashCode. Okay? So now let's see example here. So now, let's see some simple test over here. Now I'll show you slightly more complicated. Let's say we are trying to create two objects of the integer key, 39 and 39. First of all, you can see ik39_1 and ik39_2. Both of them, so they are separate objects, so their references are different. However, their contents are the same, 39. So now, if you see ik31_1 equals the other, it should be true, because we have overridden the equals method properly. So this one is no problem, right? So now, if just by seeing this in line number 5, if two keys are equal by the requirements of the hashCode, what does that mean? The corresponding hashCode should be the same. They cannot be different. But now, you will see something funny here. What you will see is, if you try to call the hashCode method on this object here, and compare it with that on the different objects, you will see that they are actually different. Why? Because as I said before, since we did not try to override the hashCode method in this new version over here, so it is going to use a default version that's inherited from the object class. And what does default version do? It simply just guarantees to generate some unique integer every time you create a new instance of integer key. Okay? Doesn't matter what the integer is, but it's guaranteed to be something different. Okay? But that's not what we want, because over here, you can see the two objects over here, even though they are different objects, but their contents are really the same. They're both 39. So their hashCode should be the same. Okay? So you can see that as soon as you see something like this, it violates the principle for the hashCode. Okay? Let's see another one here. That one is actually more influential, because over here we are trying to use the hash table. Let's see what's going to happen here. So let's see, basically a similar setup. We got K1 and K2. They're both, the contents are 39. But K1 and K2, they are different objects. So now the hashCode would be different, as we learned from the previous test. Let's try to use the hash table over here. If you say table.put K1 and D, you can see somehow the value D is associated with K1. And K1 has the contents value 39, right? Okay, that's what we know. Now, what I'm trying to do is, I'm trying to say table.get, which means I want to get the associated value with the key K2, right? I put in with K1, but I want to retrieve the value, use K2. This one here should really return back to me the string D, because K1 and K2, they are really the same key, even though they are different objects, right? However, in this case, it's going to give me null. Why? Because their hash codes are considered as different, so they will give me something different. In this case, just null. Okay? Any questions about this? Go ahead. Yeah. The hash code, okay, good question. The hash code itself is not really the point here. The point is the K1, the hash code, versus K2, the hash code, they're different. Which means when you are trying to say, in line number 15, when you say table.get K2, K2 cannot be used directly as an index. So we got to calculate the hash code. So K2, the hash code, is going to be some value, but that value there is going to be different from the original value of K1, the hash code that we put in. So that's why we got some mismatch over here. Yes, exactly. Yes, that's correct. But now the problem is K1 and K2, even though their contents are the same, but they're different objects. And why do we have such trouble? It's because we did not override the hashCode method in our class. So it's simply going to use the default version from the object class, which will always generate a different integer for us, right? That's not what we want, okay? Okay, so now let's go back there. Any questions about this example here? Okay, that's in the sample code. You can feel free to play with it. Okay, that's basically what I meant. Okay, so how do you fix it? You can override the hash code as we did before, properly. Okay, okay, I think that's about it for hash code before I move to a new topic. Any questions?
So basically, if it's the same content,
Mm-hmm.
the same hash code.
Exactly. So remember, there's only one principle for hashCode function. If the keys, the contents are the same, then their hashCode must be the same. If there's anything that doesn't satisfy this implication here, there's something wrong. Okay. Okay. If no questions, I will move on to a new topic. Okay. Something called aggregation versus composition. So somehow the concept is not that new. I think that somehow we just have to revisit certain concept that we talked about already, but in a deeper insight. Okay, so now hopefully by the end of this lecture here, we're going to learn about two modeling concepts. One is called aggregation, the other one is called composition. So we are not really trying to learn just programming. We're trying to learn software design a little bit as well. So aggregation composition is not really to say when to use when. There's no silver bullet, basically. So you have to know under what circumstances should you use aggregation. Under what circumstances should you use composition, right? You got to decide. Sometimes you might use aggregation, but it's simply not right, okay? So now I want to just define some terminology here. So we have something called container objects, which means we have some object that contains others. We'll see some example there. For example, you might say, let's say you as a student, you might be the container. And what might be the containee? So that simply means there are some objects that's being contained within certain objects, right? So let's give one example right away. Let's say you as a student, your student record is the container, okay? In that case, what will be the containees? That might be the list of courses you're taking. They are contained within your record. You might be taking 2030, you might be taking 1090, you might be taking some psychology course. So those courses are the containees of your record. Okay, so container and containees. Okay, so let's see. This is simplest example. In this case, we can say each course has a faculty member as its instructor. Just by this sentence here, can you see which one is a container over here? Should it be faculty member or should it be course? Okay. Which contains which? Somehow you want to say container. Just why don't you take a guess? Huh? Faculty member, the opposite. The opposite, yeah. Okay, we will try to gradually build a concept over here. So now we can see every time when I can tell this is a keyword. Whenever you see the word has, contains, is composed of, that means something contains something else. Okay, you will see this kind of wording a lot, in real life. So let's say each course has a faculty member as its instructor. In this case, the course is a container which contains a single faculty member objects. Okay, We'll see how this corresponds to Java code in a moment. Okay. So now this one is slightly more complicated, but it's not too bad. So now you can see that we say each student is registered in a list of courses. In this case, as I said before, students will be the container, and the course will be the containee, right? What about the second one there? I say each faculty member teaches a list of courses. In this case, who might be the container? Faculty member, right? And then the courses, a course will again be containee. So you can see this is what we have. And this is very common, which means somehow the containee, in this case the course, might be shared by by more than one classes. For example, let's say for 2030, it's one of the courses I teach. It's also one of the courses you take this semester, right? So we got this kind of relation very often. Okay, so just some other example over here. So now this is very important. It's something about sharing. So this is actually, this first example I give corresponds to something called aggregation. Whenever you talk about a container contains something else, and they're sharing the object with others, in this case it's called aggregation. Sharing is really the key, sharing. And what does that mean? Let's say today, if somehow they cancel 2030, let's say, do you think you as a student still exist? Really? No, you still exist as a student, right? They wouldn't kick you out. Let's not worry about you. Let's say me. If they cancel 2030, I will still work as a member of the department, right? I'll still be here, right? So, but my point is, let's say, in this case, in the case of aggregation, because we got sharing over here, so the containees, somehow they're independent. So even if you got rid of the containers, the containees are still there, okay? Now, we'll go to another extreme. Let's say this. So this one is a little bit boring example, but hopefully that will illustrate the point more clearly. Let's say we talk about a file system in your Windows when you're on your Mac. Let's say you have a folder over there, right? Let's make it even simple. We got only a folder, and under the folder you have only files. You don't even have subfolders, okay? Just files. In this case, it should be quite obvious to you. The container is directory, which contains files. So now, this kind of phenomenon here is not really about sharing, because you really don't have one file that belongs to two directories in this case, since we have no subfolders. Okay. So now, over here, so you got exactly. Should I just illustrate that to you? Okay. Let me just illustrate it to you on my Mac very quickly. So, for example, let's say if I go to my home directory over here. So now if I create, let's say one directory called D, which you will see something like that. Okay, let's say under D, if I have a file over there, sorry, I just created, I should have created before the class, but let me do that quickly. So now let's call that, let's say f1.txt. In this case, you will see that under D, I have f1.txt. Right? You can see that file there only belongs to directory D. So somehow F1 itself wouldn't make sense without the directory. And question here. Now, remember what I said before. If I cancel 2030, we still exist. But now, what if I try to delete the directory D? Does F1 still exist? No, because you delete it, it's gone as well. Did I delete the right directory? I think I did, right? Okay, good. Hopefully I'm good. Okay, that's about the second kind. Okay, so now for the second one, so for the second kind of phenomenon, which is called composition. Okay, so the first one is about aggregation. The second kind is called about composition. And for composition here, we talk about ownership. So the directory owns the files. If the owner is somehow destroyed, everything that it owns will be destroyed as well. Okay, so these are the two critical points. Again, this one just to briefly mention the example that we're going to go over in the next few slides. I'm going to show you some Java code as well. Okay, you have to know how to implement for each one of them. First of all, you have to decide whether for your particular problem there, it's better to have aggregation where you got sharing, or for your problem, it's better to solve it using composition where it's more about ownership. Okay, so you got to decide between these two. I'll show you Java code and see how things can be done. Okay, each one of them got some different complication. So that's why we got to learn it. Okay, the first one. Okay, first one here. So I will annotate, I just try to show you the notation here. So let me just add a new page over here. Okay, this is what we have. First of all, this is somehow something called UML Class Diagram. Okay, let me get rid of that. So called UML Class Diagram. So UML here, you might encounter this term sometimes. It's called a Unified Modeling Language. And this is actually used in the industry quite a lot when people want to communicate their ideas using some models. Okay, but for this course over here, UML is not really very important. We're just showing you some ideas using a UML diagram. Okay, I'll just guide you through the ingredients. First of all, we use a rectangle box for the class. So here we have one class called course over here. We have another class called faculty. We got two classes. Now we want to draw some relationship between these two classes, right? So there are two possible relations you may want to define. One is aggregation, the other one is composition, right? So now in this case, I'm going to draw that first, and I'll show you what I really mean. I have a diamond over here, and like that. Okay? So now this is how you can interpret that. Whenever you have that, this is what it means. This is the container. And this is the containee. You can think about the arrow always pointing to the container. Okay? So now you can see the diamond over here. We'll see another kind of diamond which will be solid rather than empty. The empty diamond simply means aggregation, which means we have some sharing over here. I'll show you how the sharing can take place in Java. Sharing basically means aliasing. Okay? So now let me just select that. So this means aggregation, which means sharing is possible. And that means in Java we got aliasing. Okay, that's something to keep in mind. Okay, that's one extreme, we can share. Okay, one more thing I want to show you, which is, let's try to make more sense out of the diagram. Okay, over here we have, first of all, we have a number over here, which is 1. Okay, this one simply means each container, which is course, contains exactly one faculty member. And usually we say there's a row for this particular containee. In this case, we just put a row over here. I say prof. Okay, so prof over here. So we have different name for this. So for the one over here is something called multiplicity. It can be any number. It can be 1, can be 2, it can be 3, or can be more than 1. Okay, you will see in that case in just the next diagram. So the multiplicity is just about how many containees can be contained. Okay, and then the English word over here is called the row of the containing. In this case, we are saying that each course has exactly one faculty object as its prof. That's how you read it from the diagram. Okay. So now I would say you're not really so much required to know how to draw the diagram. However, you should know how to read them. For example, if I give you a diagram like this, you should be able to know how to write the corresponding Java code to implement that. We're going to see that, of course. Okay, we'll see different examples. Okay. Any questions about this before I move on to the Java code? Okay. First of all, we want to know how to read this before we see the Java code. So this means we got course, we got faculty. Every course object has exactly one faculty object as its prof. Okay. Let's see how the corresponding Java code looks like. So let's say we have course, let's say we got some additional attributes. By the way, so in the class diagram, you don't necessarily have to show every attribute. You show the important ones. In this case, what I really want to highlight is the prof, okay? Where I don't have to show title, although it can be there too. So this is how we implement that. You can see course over here, we got prof attributes of type faculty, right? That makes sense. That means each course object stores a reference to some faculty member objects, okay? And then, so now here, let's say this is how we initialize a course, and this is how we set the prof, and this is how we get a prof, okay? I want you to notice one thing here. The way we do set the instructor or set a prof over here, we are simply taking, remember the call by reference we talked about in the previous weeks, in the previous class. We say that because of call by reference, what you're really getting is a copy of the address of some faculty objects, right? That's called by reference. And we are taking that objects, taking the address there and assign to the professor for this particular course. Okay, that's what we're doing. And similarly, if you want to get a professor for this particular course, we simply return a copy of the address of the instructor. Okay, that's what we're doing. That's just how we define the class. We'll see how we use it in just a moment. Sure, go ahead. This one? If it's a typo, it should be this.title is assigned the title. Yes, it's a typo. Good. I'll fix that. And now let's say we got a second class called faculty here. And this one here, we simply say each faculty has a name. And then we can initialize the faculty member objects using the name. And we can set the name to be some name. And we can also get a name. Okay? So these are the two simple classes we have. So now, this is an example this is kind of the simplest example you can get for aggregation. Because now you can see that each course contains only one instance of the faculty objects, right? Only one. We'll see in just a moment how we can create like a multiple instances. So let's see some code over here to see how we can visualize that. I'll show that to you also on the iPad in a moment. So now, let's do one by one. First of all, let's say we got two courses. We have 2030, we got 3311. We got two course objects, okay? So now, up to now, let me just add a new page and then I'll show you the iPad. It's better that we trace this properly. Okay, so this is what we have. So now we got two objects, EECS, let me just use a different color here. EECS2030, and then that points to a course objects. And remember we got two attributes there. We got title and we got prof. In this case, I'll just say advanced object-oriented programming, like that. We also got EECS3311, and that's just another objects. And then we also have title, which we initialize to be software design, and then also the prof. Initially, let's say it's not been set yet. Okay, that's what we have achieved by these two lines. Next line, let's say we got another faculty objects. Let's say Jackie here. So now we can have prof. That one is pointing to a faculty objects. And over there, we just have the name. Okay, so that's what we have achieved so far. Okay, three objects. Now we're trying to make some connection between them. That's why aggregation is so amazing. So now, first of all, we're gonna say EECS2030.setProf. Okay, let's just recall what we have. Let's just use some example here. Void set prof. So we have some faculty here, and then we have prof, right? If you refer to the code, there'll be this.prof is assigned to prof. Now, so this is the definition for the code. For the first one, we say that EECS2030.setProf. In this case, what we will do is, you can see that over here, this is the prof that we are passing over here. So we pass a copy of its address, right? So that means we're going to make a copy of the address for this particular faculty objects. And we'll set the prof attribute here to be that. Okay, that's for 2030. Okay? And for 3311, done in a similar way. So the professor for 3311 will be also pointing to this faculty objects. Okay? You can see we have sharing over here, right? You can see the same faculty object over here is shared by two courses objects. Any questions until now? And since we got sharing, we got aliasing. And if we get aliasing, you got to be careful with what we're doing here. So let me show you some examples for aliasing. Okay? So now let's say this. If I try to assert EECS2030.getProf equals EECS3311.getProf. So this should be true, right? Because if I talk about this course.getProf, it will give me this particular object. If I say 3311.getProf, it will give me this particular objects. They refer to the same objects, so they will be the same. Okay, next one. Since we got aliasing, let's try to set something here. Okay, so now let's say I say prof.set name to be Jeff. What's that going to do, right? So now let's find out where prof is. Prof is just another object variable, right? So now I say, I'll use red here. If I say prof.set name here, and then I say Jeff. Okay, prof is over here, and set name, I'm going to try to change that into Jeff. Okay, so now after this line here, you can see that EECS2030.getProf is still the same objects as EECS3311.getProf. They're still the same objects, but you can see the name has been changed, right? It's been changed from Jackie into Jeff. Follow? Okay. Mm-hmm. Now, let's do something interesting here. So now, let's say this. Let's have just another faculty objects. Just get things a little bit more interesting. Let's say we got Jonathan here. Okay, so it's going to be prof2. So now we have prof2. And then it's going to point to just another faculty object here. And then we have name and Jonathan. Okay, so now let's have a look at the line we want to do. Now, what's this one going to do? I say EECS3311.setProf to be prof2. So what does that do over here, really? So which object am I trying to change? It's EECS3311, right? Okay, let me just write that line over here. So what we have is EECS3311.setProf, and then I say prof2. In this case, I'm trying to copy the address of this object that is referred to by this. Copy the address and store that into the prof attribute here in the EECS3311. That's what I'm doing. So what does this do, really? Right? It's going to say, rather than pointing to here, it is going to point to over here. Agree? Now, if I try to run the same assertion again, okay? Let me try this. Let me ask you this before I show you the Java code. After this update here, if I say EECS2030.getProf, is it the same object as EECS3311.getProf? Not, right? Because we have reassigned that reference to someone else. Okay? So that's actually the phenomenon for aggregation, because you got sharing. You can feel free to take some shared object out or add something back in as you wish. Okay, yep, that's about the different assertions you can make. One more question. I want to make sure you're comfortable with this kind of expression here. When I say, let me just write the expression out over here. Let me write it here. when I say EECS2030 dot get prof dot get name dot equals Jeff. You can see this is a kind of long dotted notation. I'll give you more exercise today as well, but let's focus on this one here. Let's try to understand this, okay? So this is the kind of dot notation you should really get used to when you're programming in Java or any OO language. Okay? So now think about this. This is how I will analyze it. First of all, let's start with the leftmost side. We got EECS2030. What's the type? Course, faculty, course, right? I'll put course over here. It's of type course. And remember, in the course class, we define several methods there, right? One of them is getProf. So that's why so far it makes sense. Okay? And when we say course.getProf, what does it give to me? A faculty, right? I just refer you very quickly. So that's somehow the analyze you should really try to practice yourself. So now you can see that for the course, if you try to say getProf, it will give you a faculty, right? That's kind of return type. Okay? So if you go back there, so this will give you faculty. So now when you try to do a little bit more, when you say faculty.getName, that will give you string, right? That will give you string over here. And now when you say string.equals Jeff, well, that makes sense because you're comparing two strings together using the equals. Okay, any questions? No? Good. Okay, so that's the test you can go over. Let's now have a look at the second aggregation. This one is slightly more complicated. Okay, slightly more. So now, again, I'm going to just explain to you conceptually. I'm going to show you the code and then draw some diagram. Hopefully that will help you understand. Okay, so now, so this is what we have over here. Okay, so now let's say this. So what we have is this. We have three classes in the context. We have students, and we have course, and we have faculty. And again, we are trying to draw connections between these three classes. Let's try to talk about between students and course first. So somehow we want to link them together. So let's say we want to decide which one is a container. We want to say for each student's objects, they contains a list of links to some other course objects. For example, for you as a student, you might have a link to 2030, you might have a link to 1090, and etc. Right? So in this case, I will draw a diamond over here. Okay, so draw a little bit better. So this is a container. So I'll draw a diamond over here. And now I can say a little bit more. In this case, I would say students, we used to say a course has exactly one faculty member. So now we have more. A student over here has more than one. And the notation is I can put a star over here. Star simply means one or more. Okay? So typically when you see the UML diagram notation star, that means you should really use an array list or array, like collection, to implement that. That's a hint to you. Okay? And then over here we also get, I'll just say CS, standing for courses. Okay? So now this is how we interpret that. Each student has a collection of courses. That's what you have, a collection of courses. Okay? Similarly, so we can do something like this between faculty and course. So now in this case, we can say each faculty contains certain courses as their teaching duty. So now we say the faculty should be the container. So we draw the diamond like this. Okay? So now we have, let's say, I'll just say TE, standing for teaching, and then like that. So each faculty member has a list of courses as their teaching duties. Okay? Okay, that's just slightly more complicated than before. So now you can see the aggregation, the multiplicity is not just one, it's more than one. Which means when you draw the diagram to visualize, you will see an array or an array list of objects. You'll see that. Okay, questions until now? Are we okay? Okay, so now over here, so now let's see how we can implement this. Okay, let's see if I give you a diagram like this, how would you implement that? First of all, you have to declare the three classes, students, course, and faculty, that's for sure. How do we model, how do we implement, let's say for this one here, let's say each student has one or more courses as their CS. CS means courses for short, okay? So now how do we do that? First of all, you can see that we can have a students class and we just have some other attribute, let's say ID for the students. And then over here, I simply use, rather than array, I'm trying to show you different implementations here. So we have an array list of course, and then it's called CS. So this is where the aggregation occurs. And now, whenever you're trying to instantiate a new student, you give the student ID. So you say this.id, assign to ID, and then you will initialize the CS to be a list of courses, initially just empty. Okay? That's what a constructor would do. You can see that the way we implement the collection here using array list is very similar to how we did it for array, very similar. Okay? So you should really know both. Okay, now, how do we add a course? Add a course is incredibly easy. If you recall what we did last Thursday, when we try to add a new thing, remember what we did last time? We tried to do a map, right? We tried to add a key and value, like an entry into the array. We have to say, assign something to the array and then update the integer counter, number of entries. That's what we did. But now, since we're using an array list, we don't have to use this counter. It's no longer needed. So we can simply say CS, which is an array list of course, just add C. So that's one of the methods that's supported. Okay, that's what you can do. How do we, let's say you want to get the courses you have. Well, you can simply return courses, CS. You can see what you're really returning is not the courses themselves. You're really just returning the address, okay, the reference. Okay, that's about the student class. Any questions before I move on to the next class? Are we okay? Okay. So now for the course class, so we have title and, oh, that's it. The course class is very easy. Okay, so now the way we define a faculty class is very similar, almost symmetric. Again, so you can see that we have an array list of courses called teaching, TE, okay, teaching duties. And then you initialize a faculty's name and also their teaching to be initially empty. We're going to gradually add courses into it. And then we add teaching here, so te.addC, and then we can also get their courses, just return the address to the array list. Okay. If no question, let's see how we can play with this code here at the runtime. I want you to see that the runtime structure is going to be way more complicated than before. And it's actually quite normal, quite usual in the real application. So you should really get used to this. Any extra explanation you need for this code here before I move on? Yes?
We are using the course class inside the student class, right?
Yes.
And do we need to declare the course class before the student class?
Ah, that's a good question. No, because you can think about, so here, this is just a layout for the Project Explorer. So you can just define them gradually. Of course, when you first define the student class, it's going to complain you don't have a class called course, but you can just add it right away, right? Yep. By the way, so I don't have the sample code typed out for you for this example here, for the aggregation versus composition. I want you to try on Eclipse, okay? Okay, let's try to see this test over here, okay? Again, I'm going to go slowly just to show you the structure, but that's something you should really learn how to visualize. That will really help, okay? Okay, let's see how we can do that. First of all, we still have a single faculty there, so I'm going to just go back here and then going to have a new page, okay? This one's going to be more complicated, so I got to be careful when I organize the space. Okay, first of all, we have a new faculty there. Let me just see the name. Just P, okay? I have P, which points to a faculty object over here. Remember, faculty has two attributes, the teaching duties, which is an array list, right? And also we have the name. In this case, just Jackie here. And remember, in the constructor over there, we simply just create a teaching list to be empty initially, right? Okay, so I'm going to draw some empty list. So this is how I'm going to draw. Again, we're going to gradually grow it. So I'll just say empty for now, just empty. Okay, let's go back. The next one, we have one student over here, which is called Jim. And that's of name S. So we have student S, and we have students over here. So we have ID for the students, and also we have courses, CS. In this case, the name is simply just Jim. And also the list of courses he's taking is initially just empty. Not now, just empty. Okay, so far so good. And we got two more courses. Okay, we got two more objects to create. We got 2030, we got 3311. Okay, let's do that very quickly. So we have EECS2030, and that's going to point to a separate course object over here. And we have title, okay, and then we have prof over here. And then the title advanced object-oriented programming over here. Initially, prof was simply just null because it's a reference type, okay? And then we have the second one, EECS3311. And then we have this course title software design, and then prof will also be just null. So these are the four objects we have created so far. Let's see how we can link them together. Okay, the way you link them is defined by the methods that we are presenting in the previous slides. Okay, so let's see this. So now, first of all, how do we set a prof? Okay, we want to set a prof for both courses to be P. Okay, so what we can do, I'm going to use a different color here. So when you say EECS2030 dot set prof, and then to be P, and then EECS3311 dot set prof, and also P, the blue one. How do we do that? So we're going to say, for example, when you say EECS2030 dot set prof, the prof field over here, rather than pointing to null, it is going to point to wherever P is pointing to, right? Similarly, for 3311 here, the prof field is not going to point to null anymore. It's going to point to this object over here. Oh, I beg your pardon. Oh, good. You guys are not sleeping. That's good. I was so worried. Okay, good. I agree with you. That should be over here like that. Yes. So now you can see we got aliasing here. So now, question for you. How many ways can you refer to this particular objects? How many ways are there? I'll give you a hint. See how many arrows are pointing to it. 3, right? So, okay, that's as an aside. That's something you should really know. So now you can see that for this particular object here, aliasing, when you simply say P, that's referring to this object here, or you might say EECS dot prof. This also refer to that, right? Or you might say, oh, sorry, EECS 2030. 2030 dot prof. EECS 3311 dot prof. So these are the 3 names that are actually referring to the same objects. That's aliasing. So now, again, you should really try to get comfortable with the dot notation. It's very useful. Okay. Okay, that's about this one here. So now, how do we? Let's say we want to add teaching. Okay. Let's say we want to add for this particular faculty member add teaching. Okay. So now let me just do that over here. So now you want to say p dot add teaching EECS2030 p dot add teaching EECS3311. Okay, let's see how we can do that. Let's start with this line here. When you say p dot add teaching 2030, at the moment the array list over here is empty, right? So we're going to grow it into one single slot. So now let's grow it first, and index 0, and then that one is going to point to 2030. That's the first course. And the second line here is going to grow the array again into 2 slots with index 1. And then that one is going to point to 3311. Okay? Now, similar question for you. Again, we got aliasing. How many possible ways can you use to refer to this object here? How many? I heard 2. Okay, I tell you, one of them is simply EECS2030. That one's easy. What about the second one? P dot, good, that's a good start. P dot TE. And if you say P dot TE, that's only referring to the whole array list. Index 0, that will refer to it, right? Very good. Okay, let's write it down again. Okay, so again, we got aliasing here. So you either have EECS2030, that's one, or you can say P dot TE. This one only refers to the whole array list. And the array list supports the get method. You can say dot get 0. Right? That will refer to the object there.
Are we not supposed to get away from EECS3311 to P then to EECS2030?
You see, if you start with EECS3311, right? If you say that one dot prof, I see what you mean. Yes, very good. I agree. Everybody heard that? I'm gonna write it down. That one is actually very good. So the green one. So I'll write it here. So it's gonna be EECS 3311 dot prof. First of all, let me just try to highlight this. This one's really interesting. When you say EECS 3311 dot prof, it's going to refer to this particular object here, right? And now we are in the same starting points. And now we can say dot TE dot get 0, right? I mean, to be complete. Dot get, dot TE dot get 0. So this is just another one, okay? So these three are all acceptable. Yes, you first. And then, yeah.
Find these objects. So of course, only had a title attribute. It didn't have a prof attribute.
No, it does over here.
But in the one of the previous slides, when we defined add teaching method.
Remember, that's one of the attributes. You can say, or you can say EECS3311 get prof. That's also the accessor method you have. But just for the diagram, just easier for me to link it. Yeah. The same. The same. Yes. Okay, kind of know the idea, right? Again, you can see every time we try to say dot, we are following the link in the runtime structure, right? Okay, let's try to do more. It's going to get more and more interesting. Okay, now one more. So now let's give 2 more updates. We're going to say the student that add course, EECS2030 and EECS3311. Okay? Now, let's see I'm going to use red. So now student S, which is here, S dot add course, EECS2030, S dot add course, EECS3311. Okay, it's going to be similar, right? Initially, this list of courses is just empty. Now, for the first one, we're going to grow it to index 0. And then this one here is going to point to this course object, EECS2030. And the second one is going to be, one here is going to point to EECS3311. Okay, 2. Done in a similar way. Okay, you can see the way it turns out to be a little bit sophisticated, right? Okay, let's now see. Now let's try this. If I say this one's easy, I simply say EECS2030.getProf, which means EECS2030.getProf, I get this object here. And then when I say students.getCS, which means get the list of courses for this particular students, and then get the first course that he's registered, and then get the instructor for that, right? In this case, we're going to start with student S over here, get a list of courses, get the first one, which refer to this one here, and then get the professor for that, right? Which will be the faculty member, right? So it's also linked in. Okay, that's kind of the idea, okay? Any questions? So if I give you maybe the class definitions, I give you some test, so hopefully you can trace that manually by yourself, right? So the idea is in the lab test, you wouldn't have enough time to type out. Of course, you can simply try in the Eclipse and see if that assertion is true or false. Of course, then you can try that. But you wouldn't have time. I think you better just try to draw some diagram to visualize. I think that's an important technique for learning OO. Yes? Yes. Array list, yes.
Because I noticed that array is with no modifier, right? Without access modifier.
Oh, right. I see what you mean. Actually, that was fine because we assume that every class is in the same package.
So can I just use S from the array?
Okay, what you're saying is this. Okay, let's just get back to your question here. So here, let's say here, for example, we're talking about this method here, right? So we just return the CS, which means the reference to the array list. Just say CS. I would say it's better to somehow change that into this. The reason is, at the moment, we simply say every time you want to get a list of courses, you just pass the same reference. But later on, when we talk about the second kind of relationship, which is composition, in which case you don't want to share anything. So yeah. Mm-hmm. But also it depends on how I ask you the questions, right? Yeah. I would say if I didn't say you cannot, feel free to do it. Okay. Okay, that's about the second kind. So I'll leave the rest of the assertions to you. So I kind of solved the most complicated one for you. Okay, just aliasing. Okay. So now just a little bit more about dot notation. Okay, very quickly, and then we'll get to composition. Okay. So now this one here, I will just do one class with you, and then you will get the idea. I want you to complete the rest of the exercise. So this is really to help you when you're trying to define your classes, how can you use a dot notation to make definitions? Okay, I'll give you some idea. So let's use the same model here. We got students, we got course, we got faculty, okay? Let's say this is how we start with. Student has ID, has a list of courses, course has a title, has a prof, faculty has a name, and also has a list of teaching courses, okay? That's what we have. So now, as we learned from the previous two diagrams, whenever you got aggregation links, they talk about how you can navigate between the objects or classes, right? It's really about how you can travel among the links. Okay? Let's now see how we can do that, not on the object diagram there, but in the class definition. Let's get some idea. For example, let's say if I'm in the student class over here, if I say simply CS, I'm referring to the attributes. So we are talking about an array list, right? The list of courses. But if I say CS of a particular index I, let's say I is valid. So what do I mean? I refer to a particular course of that students, not just the list of courses. So it really depends on what I'm writing. Okay, let's see some, just show you one example. Let's say this. Let's say we have the student class over here, so you can see all the context here. So there are 3 classes that are involved. So now let's say this method here, this is very easy. I want to return the ID of the current students. The current context is students. So what should I do? Return what? Just ID, right? This one's easy, just as a warm-up. Let's say this. Let's say this method here takes an integer I. Let's say if I is 0. When I say a student.get course title 0, I want to get to the first course, for the first registered course for the students and get its title. How do I define that over here? Return what? cs.getI.title. Everybody follow that? So first of all, since I'm now currently in students, so I can either say ID or CS. So now in this case, I can say CS, which refers to the array list. I want to go to a particular one, so cs.getI. And then once I say getI, I'm now moving to a different context, which is course, and then I get the title. Okay, not too bad, right? Okay, you're not allowed to answer in this case. Okay, let's try this one here, and then I can leave the rest to you. Okay, now let's say this. I want to go to, let's say, if I say get instructor name 0, I want to go to the first registered course for this student here, and then find out who the instructor is and get their name. Return what? Good. Hopefully this will make sense to you guys. This, starting with the current class, .cs.getI.prof.name. Let's try one. It's a side notes. Let's say, let me make it concrete, not just I. Go to the first course of the students, and then get a title. Actually, I don't want to complicate myself. Okay, never mind. It's too complicated. Yeah, it actually is no point. Okay, anyway, so that's kind of the idea. So you can now see that in the next slides, I just show you more method here. Now the context is different. It's now course rather than students. You can go through the rest and see how you can use a dot notation. Okay, the same idea. And also faculty. Okay, any more questions before I talk about composition? Are we okay? We got 5 minutes. Let's see how far we can go. Okay. Okay. So now over here we talk about a different concept over here. In aggregation, we talk about sharing. So now we talk about composition, and there is no sharing. It's only about ownership. It's about something is an integral part of something else. For example, let's say the file is an integral part of a directory. You can see a file has exactly one directory as its parent. And the directory has multiple files as its files. Okay, that's how we read the diagram. Okay? And let's just for this no sharing. Okay? And now one thing to note, you can see that the way we draw the diamond is different. It's now solid diamond here. So that means, as opposed to empty diamond. So that means now we don't have any sharing. Whenever you want to declare some method there, if it allows sharing, that's not good for composition. So we're going to see examples. Okay? Let's just move on. Again, let's try to define a file class first. File, we got name, and then this is the file class. Very easy. You just have a name of the file, and then just initialize the file object using its name. Okay? And then we have a directory. Now I switch to a different kind of implementation, right? I don't use array list anymore. I want to make sure you're comfortable with both. So now we have name of the directory. You have list of files. You can see the directory is a container. It contains an array of files. Also, we got a number of files over here, right? Okay. And then we can actually initialize the name to be the parameter and also create an array of size 100, pretty much like what we did last Thursday. Okay, this one shouldn't be strange to you. And also, how do we add a file? Add a file using NOF and then increment it. Okay, we have seen diagrams like that last Thursday. Make sure you're comfortable with this. Okay, so now let's say we want to create a directory structure like this. Directory D, F1, F2, F3. So how do we do that, right? Let's see that. So what you can have is directory D1, and then we have directory, so you can see just name D. And then F1, F2, F3, and then, so now, there's one thing I want to show you over here. Let me ask you something. When I say D1.add file, and then I pass a name, I'm not really passing an object. I'm only passing the name of the file I would like to create. So where is the object created? The object is created by this method itself. So if you go back to the add file over here, you can see this is where I created the objects, which over here, right? Okay. So you can notice that when you draw the diagram, there is no sharing. Okay. Okay. And then we can make sure this is how we can make sure the file name over here. Okay. Let me just show some diagram over here. So now this is a diagram I would like you to study very carefully before Thursday. Okay. So now, lab test number 2 is going to be next Thursday, right? To motivate you to study more, it's going to cover until what I would say on Thursday. Whatever I will finish on Thursday, it will be covered on this week, not last week, this week. Of course, including this. Today is only Tuesday, right? Yeah. Okay, guys, but I will give you more idea on Thursday why you should really prepare. Okay? Go over this diagram very quickly before Thursday.